Okay, so this is another in the History of Hydrology video interview series. My name is Keith Beven and I'm here in Lancaster at the house of Professor Peter Young, who's now Emeritus Professor of Environmental Systems, I think, at Lancaster University, where he's worked since 1981, that's right. I think. I have to express a sort of vested interest here in that Peter and I have been colleagues and friends since I joined Lancaster in 1985, in fact it was Peter who invited me to apply for a job at Lancaster originally, so we've worked together more or less ever since then.
We were fortunate to get you.
Well, you have an interesting background, Peter. I know that you grew up in a relatively poor area in the Midlands, and you started with an apprenticeship in the aerospace industry, I think, but you went on to do a PhD at Cambridge, which is really rather an unusual trajectory. So can you tell us a little bit about how that happened?
Yes, my wife Wendy and I were both born in a council housing estate in the West Midlands at a place called Bloxwich. Now, I had an unusual upbringing in the one sense that I had effectively two fathers. One was my father and the other was my brother, 11 years older than me. Now, he was an electronic engineer with the General Electric Company in Birmingham, and he was a big influence on me, and he was the one who suggested what I should do. And in fact, he, realising at that time that it would be too costly to go to university and pay ourselves, it was either get a scholarship or do something else. And he suggested a student apprenticeship, which was a 5-year apprenticeship in which they sent you to university. Mm-hmm. And in fact, I applied around and I was surprised in that I got accepted, I think. I got invited to interviews for 3, and the one was with English Electric Aviation in Wharton Aerodrome, quite near here. And that seemed to me to be the one that was, the most likely to be taken up. So I went there as a student apprentice, in which you were sent to university, and it was Loughborough, which at that time was a college of advanced technology. Yeah. And you went there for 7 months of the year, and the rest of the year you spent working in industry, and that was for 4 years. And so I did that, and I thought, well, I'll probably stay in the aircraft industry. But the head of department, aeronautical engineering department at Lancaster, he contacted me and said he had a research studentship, and that was I interested. And to cut a long story short, I don't want to bore you, I went there and I was there for 2 years, and I did research using hybrid computers. Mm-hmm, right. That is analog connected to digital. Yeah. And of course these were some of the first hybrid computers. Yeah. It was very odd. Again, interesting discussion on what they were like, but I won't go into that.
But pretty historical.
Yes. Now. But this led, I worked there with another guy, and it led to us being given a prize by the analog computer firm, whose name evades me at the moment, American one, and for the work we did. Now, just at that time, they advertised Whitworth Fellowships, mm-hmm. And I'd never heard of this, but I'd heard of Joseph Whitworth. And it turns out he endowed these for research, for apprentices in the first instance, not student apprentices, to go to university. Mm-hmm. And it had evolved over the years, and now there had been 30 to start off with, and they went to to do an ordinary degree. But now there were 2, and they were
PhDs.
PhDs. And again, to cut a long story short, I applied, and to my surprise, I got it. And then, to my surprise again, I was invited to talk to the principal, who then became the Vice-Chancellor when I returned into the university. And he said, I hear you've got a Whitworth Fellowship. He said, well, that's good, because I'm a Whitworth Fellow too. I began to have some doubts about whether I'd done well at this interview or not. Anyway, he said, what are you going to do with it? Because it turned out it gave a lot more money than any grant you were getting at the time. And he said, you can go anywhere, can't you? And I said, yes. I said, well, I thought I'd stay on and do a PhD here. And he said, oh no, you don't want to do that. I've arranged for an interview with you for Cambridge. So I had to go because he'd arranged it. And I went to the engineering department, and Professor Coles was there, Professor John Coles. And in some funny way, there's me with a strong Midlands accent, and there's this man who's very rich and has got 3 farms, one in the Lake District. And we got on well together. Very strange. Anyway, again, to cut a long story short, I did a PhD there, so that's how I got to Cambridge.
Right.
And, so it's an odd story, isn't it? So, but like all my life, a lot of luck.
Yes, for many of us, in fact, yes.
And so, and it was a good time to be growing up, of course, and going to university.
So was Coles your supervisor for the PhD?
No, someone who you will have never heard of, and he's disappeared from view now. I don't know where he's gone. But he didn't really supervise it. At Cambridge you did your own thing.
Yes.
And then they kind of now and again saw you and...
Even when I did my PhD, the grant was actually given to the student, not to the supervisor.
That's
so
right,
you
exactly.
could ignore what your supervisor said if you wanted to. So yes.
So it was more or less you got on with it.
And the topic?
Well, the topic was basically to look into automatic control, which I'd moved on to from aeronautical engineering. I'd found that aircraft flew as much because of the automatic control as they did because of the
even more so now.
More so now. And a lot of the military aircraft, and it's still the same, are unstable without automatic control. So I was very interested in that, but I'd also realised that in order to do the design you needed a model, and so I got into modelling, and so I was effectively looking to see how I could use the new hybrid computer that they were going to get in order to model systems. And unfortunately, by the time I left, it still hadn't been delivered. And I think I was the first analog to digital communicator on a bike, because I had to work in Madingley Road on the analog computer laboratory, which was way out there, do the runs, get the data on paper tape, and then bring it back to the main site
to feed it
on
the
my
digital
bike,
side,
and then feed it in to see. And this was all preparatory for the hybrid computer, which it never came.
Yeah.
Anyway,
You got the PhD anyway.
I got the PhD. Yeah. Actually, I got the PhD when I came back. Because out of the blue, I was I won't again go into this, but Bob Spear, who we both know, was a PhD student with me at the time. But he finished a year after me, and he suggested a job in the States, and I didn't.
Okay, so that was before you actually submitted your thesis.
That's right,
you went to the
so
States.
I went to the States before submitting it.
Right.
And I was
So
going to write it up while I was in.
So a rather remote location in China Lake.
Well, indeed, in the Mojave Desert.
Yes.
Foot of the Owens Valley, and in between the Sierra Nevada and the White Mountains, right at the bottom. Anyway, he effectively arranged this job, and I didn't think I wanted to take 2 children to the Mojave Desert. But they rang up and said, well, we'll offer you this. And tell you the truth, it was so much they offered me that I couldn't very well refuse. So we went out with 2 small children, and we found ourselves in the Mojave Desert. And it was 1968, and if you wanted to be in the United States at any time, 68 to 70 was the time, and that was the time we spent. And it was an amazing time. I have to say that I wouldn't have missed it for the world.
Right. Yeah.
And I worked on, again, this time, modelling the various airborne vehicles that I won't say what they were,
Right.
and that went very well, and the automatic control thing, and I'm still on automatic control. I'll mention one little thing which shows you that you should never give up. When I got back to Cambridge, which is where I went
1970?
1970,
Yeah.
a visitor came from MIT called Jan Willems, who unfortunately has died prematurely, I believe. And we got to talking about a thing I'd come up with, a design approach. And we wrote a paper together, and he was much better theoretically than me, and he wrote some small amount of theory into the paper. And we called it the multivariable servo mechanism system. And we wrote this paper, and it was submitted, and it was accepted. And that paper has never been cited, ever, right? Until 4 years ago. And now, believe it or not, it's my most highly cited.
Really?
4 years ago, somebody found it. Right? And so it just shows you should never give up.
Yeah.
Anyway, we were there for 2 years, and then out of the blue, I was applying for jobs, mainly with the civil service in this country. Professor Coles contacts me and says he's got a job if I want it, and I hadn't asked him. So again, luck.
Yeah. Yeah.
And I worked then for 6 months for ICR, but at Cambridge, and financed jointly. And then ICI ran out of money or something like that. Anyway, he then asked me, did I want to apply for a lectureship? And I did, and surprisingly, I got it.
Right.
And it was at this point where the environment came.
Yes, yes.
Because a student named Bruce Beck,
Also well known to us.
also well known, yeah. He came, and he had, I believe, a chemistry background. And in the interview, which was with Professor Coles, he said that he would like to do something to do with the environment. And in the then discussion about who should supervise who, he said, well, I think this guy will turn him down because he wants to do the environment, and you've got nothing to do with the environment. And I said, well, look, he looks a good student. And he said, well, if you think he's a good student and you want to do it, you can do it. And the outcome was we did a study of BOD and DO in the River Cam.
In the Cam, yes.
And we collected data every day for 6 weeks. And Wendy and I collected the data at weekends, and because he was off clubbing it or whatever, and he did it during the week. And the outcome of that was
you had a real-time series. Real-time series
straight away, yeah. And we managed. In my mind at this time was the idea of trying to infer the model from the data, which later called database mechanistic modelling, but in a form that had a mechanism you could see what it meant.
Yes.
And so that these models were like that.
Yeah.
And they worked quite well, and they gave good insight into what was happening, algal formation in the river, etc. And so that went very well, and out of that, he was going to go to the Bedford Ooze to talk to some people there, and he broke his leg, so he couldn't go, and I went in his place. Right. And again, to cut a long story short,
I'm sure that counts as luck, but
well, not for him. Really. And I went, and the outcome of that, about a year later, perhaps more, was the Bedford Ooze study,
Yeah.
which we were funded to,
Yeah.
or I was funded to do. And of course this meant now I'm moving, I am
More into
the environment now.
Yeah. Yeah.
I'm still doing other work
Yeah.
to do with
Yeah.
electronic engineering control in particular. And I'm writing papers on that as well, but I'm mainly doing the environment. And it's interesting that we're in the same building as statistics, so I actually had quite a lot of contact with statisticians
as well.
And so anyway, that's more or less went on. And, I did quite a bit of interesting work, I think, in that area with Bruce. Paul Whitehead came as an RA, and it all went very well. Until again, out of the blue, I got a letter from the Royal Society, by the way, from a chap called Frank Fenner, who I never heard of. But it turns out that he's very well known in Australia. He was the man who did the research on myxomatosis.
Okay. Yeah.
And in fact, as an interesting aside, he actually took the stuff to show that it was okay for people, they wouldn't be poisoned. Him and his boss at the time. But anyway, he'd become the head of the medical research at ANU, but he was retiring nominally from that post, and he was setting up a Centre for Resource and Environmental Studies.
Yeah, correct.
And he asked, I didn't know anything about this, but he asked if he could come and see me. Anyway, he came and we had a discussion. He told me what the situation was. He was setting this up, and he said, well, I've been told that you're a systems man. And I said, well, I suppose that's how you could describe it. He said, well, I'm looking for somebody to head the systems division within the centre. And he said, are you interested? And I said, well, I'd have to think about it. And he said, well, it'll be a professorial fellowship, he said, and you can have it if you want it. So
that's a good sort of job interview.
I should tell you that, well, I'm giving away, aren't I, the fact that I have only ever had one interview in my life, and I didn't get the job.
Right.
But so this one, then I had to make the decision. And we had some friends in Australia. Wendy's uncle and auntie lived in Australia, and we thought, well, if you stay in one place for too long, you don't like it very much.
You hadn't been in Cambridge that long, but
that's right. In total, I'd been there 8 years.
Yes.
So
before
it was
after
quite, and I got to know it. And anyway,
so now
we decided we'd leave.
Yeah. Now we're in Australia.
Now we're in Australia, in the Centre for Resource and Environmental Studies.
That was in ANU.
In ANU, and it was being set up, and someone who you knew was coming in to run the master's course, and that was Daniel Smith.
Right. So yes, we have a common friend there. Well, friend. He was my tutor at Bristol for a couple of years before he went to Australia. But
that's right.
A very nice man.
Very nice.
Sadly lost as well.
And his wife was very nice too. And obviously I got to know him well. And I discovered that he was an expert at putting tracers into rivers, and this had interested me.
He was a limestone hydrologist, a karst hydrologist.
That's right, indeed.
Went to back in the UK.
A lot of caving.
A lot of caving for a lot of tracing.
Anyway, to cut a long story short again, I managed to get a grant from the authorities in Canberra to do a study of the Molonglo, or the river system there. The two rivers join, and Canberra's just above. Its effluent was going into the river,
right.
And so there was where it would get to, what effect it might have. And we got a grant to do this, and obviously one thing to do was tracers.
Yeah.
So we put tracers
Put the
in,
mix in.
and we collected the data. Again, Wendy and I at weekends taking samples. And, so I would say that as a hydrologist I have actually done some work,
Some field work,
field work. And that went quite well. Not as well as I'd hoped, but it was all right. Mainly it didn't go as well as, because it was very difficult with the small team to do a big stretch and river.
Yeah.
And it gave me a realisation that, you know, you had to plan these things better than I was planning.
Although Dingle was not that well known for his planning.
Well, Dingle
There are
was
various stories about
somewhat
him.
haphazard.
Yes, various
I don't
stories
think-
about him and his tracing experiments.
Yes, he would do. I always recall he was running the master's course, but he didn't go for very long, and so he quickly became doing his research.
Right,
You know, but,
yeah.
And he used to do odd things, and there are lots of tales about Dingle.
Yeah.
But he's a great
another time,
guy,
perhaps, yeah.
and he knows how to do tracers.
Yeah.
Rather than
Yeah.
concern about it. So that was that, and then we got another study which was on the Peel Inlet in Western
Yeah.
Australia,
Yeah.
and another one which was in the Northern Territory,
Mhm.
which was to do with the uranium mines.
Right.
And so we carried out these various studies. And the Peel Inlet one was the one where Bob Spear and George Hornberger came for a year,
Yeah.
and they wanted to be involved.
Mhm.
So I involved them in that study.
That was more geared towards algal,
It
modelling the
was.
algal.
Yes, there was
exposure.
a macroalgae
Yeah.
had formed in the Peel Inlet.
Mhm.
The Peel Inlet had a very narrow entrance,
Yeah.
and so in a sense it was like a lake, but it was salt water, but very salty because you know it was cut off. And this algae formed, this macroalgae, and formed great sheets on the surface. Well, it bred on the on the bottom, floated to the top, and was then blown into the onto the beaches. And of course, this was a holiday area, so they wanted this cured. So we again did various studies, some tracer studies, together with people in Western Australia. And George Hornberger and Bob Spear weren't involved in that.
Mhm.
They were looking at, I'd asked them, because I knew what George Hornberger did because he'd visited me previously, and I knew what Bob Spear did.
Mhm.
Now Bob had done Monte Carlo analysis for his PhD, which was on rocket engines.
Yeah. Right.
And George obviously was known for his modelling of hydrological systems. It struck me that bringing them together on this Peel Inlet was a good idea.
Yeah.
And so together with me we got together and we came up with an idea of how it could be done and whether we could try and establish a model that would be able to explain, if possible, what was happening.
Yeah.
And of course it was a model that I didn't particularly like because it wasn't a database model.
No.
It was a hypothetical model.
Yeah.
And in order to put some uncertainty into it, Bob came up with what he called global sensitivity analysis. And so the basic modelling study was that. So looked at all different possibilities by playing it in that sort of way. And this suggested two possible sources. They looked at phosphorus or nitrogen nutrients, and it seemed likely that it was either phosphorus doing something and getting in from they thought the toilets system, the sanitary system, which was all dry, there was no piped sewage. So they were thinking it was getting through sand into the
Inlet.
but the other one was that it was nitrogen and was coming down the river from the farms. And that in fact what it was.
Salt,
Yes, that's what it was in the end. And so then we made suggestions that it should be managed better, etc. But then I'm trying to think of the names evade me these days, but there was a hydrologist in Perth, an American. No, he went to America afterwards. His name was like Hornberger, but I've forgotten it.
Imberger.
Imberger,
Yeah,
that's right.
Who ran the hydraulics
He did.
lab in Perth.
That's right.
Yeah.
And he'd
The
been,
old Imberger.
yes. Now, he was put out that this Inlet study had gone to us and not him, as I understand anyway.
That sounds like your...
Anyway, he didn't want to be around while we were doing it, so he went off to America, California, I think. Anyway, when he came back, we had the final meeting, and he told the assembled people that what we'd done was all rubbish. And there was an obvious solution to this, and that was you punched a hole inside of the inlet and let the water come in from the sea, and it would mix and it would get rid of the algae, which was true, but you know, it probably would. But on the other hand, we had not looked at that since this was a major expenditure of money, and we didn't think...
He was a hydraulic engineer after all.
And he was very well respected there, so in the end they punched a hole through the side of Peel Inlet. So that was that, and that was quite nice because we were able to drive over by land across the whole way across Australia to get there, which was very interesting. The other one was in the Northern Territory, and this is where Hornberger and Spear persuaded me that they wanted to have a trip somewhere. So I said, well, I was supposed to be going to help with Dingle to do this study, which was to release dye into the floodwaters in the wet season from where the uranium mines would be and where the tanks that they would be going. Because the idea in the uranium mines was that they would release the stuff that was being collected into the flood.
If it lit up on the floodplains.
Where would it go?
Yes.
It was the question. Anyway, I was supposed to be going, and I could see they wanted to go, so I didn't go and said they could go because we had the funding only for limited. And so they went and helped out, as I understand. Although I tell you the truth, at this point in time, I was getting to the feeling that this wasn't going to work very well, because how can you put dye into, you know, that sort of situation and hope to trace it over an enormous area? Now it's true that it flows in certain ways across the floodplain, but the floodplain's enormous. And so the thing was done, but it never produced enough data that one could ever look at modelling. So I found it not... It was interesting, very interesting, you know, and I got a trip up there earlier on to survey what was going on, and I found that very interesting, of course. So in the end, we wrote it up, but I don't feel that we achieved anything. Just at this time, I met another guy, his name was Beer, and he... how did it come about? I have to think. I had by this time found that you could take these data, the tracer data, and if you had enough of them, so it meant sampling fairly quickly, that I could take the techniques for transfer function modelling that I'd developed, and you could get a transfer function model that seemed unbelievably, for low order model, would fit the data almost perfectly.
Yes.
So I got the feeling that there must be a way of interpreting this, and Tom Beer was interested in it, so we got together and we came up with the idea of what became the aggregated dead zone. And we found that somebody in New Zealand had been looking at it in terms of a partial differential equation. And they had put dead zones in. What we were finding was that the whole thing was dominated by the dead zones. That the normal dispersion wasn't very much at all. And so we wrote a paper on that, and I found that very interesting. I think that's covered most of what we did there.
Well, we haven't mentioned Captain yet.
Yes. Well, Captain started at Cambridge. So at Cambridge, I decided that we needed to put. I was building up. It was all coded in Fortran at that time, or BASIC. And I'd coded up the various algorithms that I was thinking of at the time, and I thought they ought to. Oh, there was a move, I think, in the control area to develop packages. And so I thought we ought to put these into a package. And we were going. There was a conference at somewhere anyway, and there was a competitor in this area who had produced a package, and I forget what it was called, but it had a rank, and I thought mine has to have a bigger rank, and so I thought, well, what's the next rank? And it was Captain. So I thought, well, can I put together Captain?
Okay, so the name came first, so what does it now stand for?
Computer Aided Program for Time Series Analysis and Identification of Noisy System.
Wonderful,
so that's how Captain came into existence, and we developed it, and it just was a package, so you could take them and you could use them, the various routines. So when I got to Australia, we decided that we should try and do it as an interactive package, and they had an interactive computer there. And Tony Jakeman had come as a research assistant, and he had a maths and computing background, particularly computing. And so he and I got together, and he worked on the multivariable things, and I worked on single variables and continuous time. And in the end, we managed to put all of these together. And I had programmed them all in BASIC. He put them in Fortran. But just at that time, we had a sabbatical, and the outcome of that sabbatical, which was in Cambridge, was that I met Terence O'Donnell, who was from Lancaster, and he contacted me in Australia and said that the head of the Environmental Science Department was not well, and he was going to take early retirement, and was I interested in the job, head of Environmental Sciences at Lancaster. And I can't say I had thought about it very much, but again I came up for a chat. Perhaps it was an interview, I don't know, but I didn't see the way as that. But the outcome was that they asked if I wanted the job, you see. I think they were a bit like they'd got to find somebody quick. Anyway, they said, well, you can have the job, but there's one problem. Mrs. Thatcher has made such big cuts that we don't have the money.
Mm-hmm.
So, sorry, we were going to offer it to you, but we can't. And we're not quite sure what we're going to do now, because Terence O'Donnell wouldn't want to be head of the department.
No, it wouldn't have suited him.
He wouldn't have suited him, and he had sugar diabetes, and so he didn't want to take on any stress.
Yeah.
So I went back to Canberra, and I was expecting to stay on there. All of a sudden, on Boxing Day, Christmas, I got this telephone call from the Vice-Chancellor of Lancaster saying, we found the money, do you want the job?
Mm-hmm.
So we then had to make the decision.
Yeah.
I was for staying in Canada,
Okay.
but the rest of the family wanted to come to back to Britain.
Mm-hmm.
That's not to say they didn't like Australia, but it
Yeah.
was just that my mother who lived with us, I think my wife, Wendy, and the kids, except for the youngest, all wanted to come. And the elder ones, of course, were in their teens and they wanted to get to Europe,
Yeah.
as most Australian teenagers wanted.
At that time, yes.
Yeah. And so I accepted it and came in '81 here and been here ever since. I didn't think I would ever stay anywhere for this long,
No.
but it shows there's something about
This
being
area.
here, which I think you
Also
proved too.
didn't expect to stay so long.
Is that it's not a bad place to live.
No. But we actually first met in George Hornberger's office at the University of Virginia, where I was teaching at the time.
That's right.
And
A fortuitous meeting.
a fortuitous meeting. You were on your way back to take the job in
That's right.
Lancaster, and I was finishing up in Virginia. I was in my last year there because I had leave of absence from the job in the Institute of Hydrology.
And you were nominally, you were going back to the...
Yes, but we started talking about tracer experiments since I was also interested in tracing experiments, so we realised we had something in common, if not modelling techniques in common. And so, yes, you went back to Lancaster, I went back to Wallingford, but then you invited me to apply for a job in Lancaster.
Yes, well, Terence O'Donnell was leaving,
Yes.
and so his position
retiring,
became available, and unfortunately at that time it was only a lecturing post, and I felt you could be appointed at a higher level than that, at least senior lecturer, but I wasn't able to get the funding, and I remember saying to you, well, that's all I can offer you.
Yeah.
You know, you can come if you like, but I believe that you could, do better.
Progress.
And surprisingly, you then said, well, I'll come. So for 7 years I was the head of department. You came. I tried to get on with my work, and I managed to do quite a bit.
Oh, yeah.
But it was a trial. I was eventually able to give it up and get back to doing research. And then by this time we had done the work on the ADZ.
Well, we managed to get a Research Council grant to do more tracer work, and we employed Steve Wallace to do that. He went later to work at Heriot Watt University.
Yes, and Steve worked very hard on it.
Yeah, and once he moved to Edinburgh as well, continued the tracer work with his students, because I think the stream that runs through Heriot Watt campus is the most traced river in the world now, because of successive student exercises.
He took to it very much, didn't
very
he?
much, yeah.
And he was helped a lot by the technician whose name evades.
Charles,
yes. And Charles worked hard on it as well.
In terms of, we had these little Epson.
That's right. I've still got one.
You've still got one, have you?
Yeah.
Epson portable computers at the time.
That's right.
Things all digital now, of course.
But it worked very well, didn't it? I mean, we got good data sets, and I think the outcome was more than we expected in one way, wasn't it?
Yes, and a couple of theses as well, Hannah Green's, and in Portugal, João Ribeiro da Costa,
yes.
working on Portuguese data.
That's right. Yeah.
Although there we had to deal with dynamic flows a lot
That's right. So they
steady state flows.
they had releases of
Yeah.
water down the River Arve, and it was quite a wild river, and so it wasn't easy to get data.
Yeah.
So again, I don't think the data was sufficient to do a great job, but I think it helped, and I think the work in total was quite good. And, so I was pleased to see that, and it also led to some trips to Portugal, which I was pleased to go on, except that they lost my luggage once, and I found myself in a suit having to go to look at some field work on the River Arve, and so I had to, we had to go and purchase, some clothes that I could work in.
Yeah.
So,
Captain continued at Lancaster.
It did.
And then became a MATLAB toolbox.
it did, and the force for that was Wlodek. Now Wlodek, I was approached by the Vice-Chancellor to say that his friend in Poland, his son would like to come to the West and get a job. And he said, "Have you got any jobs?" Well, I looked around, and because he was putting pressure on me, I looked around and I found some money to employ Wlodek for, I think, 3 years or something. Anyway, Wlodek told me about MATLAB, and I got a copy of MATLAB. I was quite impressed, because basically the advantage of MATLAB then, I have some deleterious comments, I would say, about MATLAB now, but the latest version. But at that time, it was something I hadn't met. It's easy to program. It's a bit like BASIC in many ways, as you know. And we discovered that we could build a toolbox, and MATLAB had toolboxes, in which you had various routines, M files as they're called, and we realised that Wlodek, who was very good with MATLAB, we could do some what we called captainising, which meant we converted, or he converted, the things I was producing in BASIC into MATLAB with a front end, effectively, a thing that handled everything and caught any errors, told you about things and things like that. And Wlodek did a great job, and we got the first version of Captain working. I think it must have been the early 90s, something like that. And it's carried on developing ever since. And I work with it day
Wlodek's still in Lancaster, but of course another one who hasn't left.
Yes, Wlodek, fortunately, were able to keep him on, and he is just retiring, by the way. So it shows you how time passes on. And so Captain then has become quite popular, I think. One of the things the thing that's most popular is not the things I would really like to be popular, which are the transfer function estimation, particularly in continuous time, because I think that's not used enough in hydrology. PDEs, yes, but not ordinary retrograding. And so, the one thing that I'd done with a young man at the time, Cho Enji, who unfortunately died this year. He had a heart attack and died. And that's very sad for me, particularly because he became a friend. He didn't do any of the fundamental development of the algorithms, but I gave him the task of programming them up in first instance before they went to Wlodek. And they were to do with what is called dynamic harmonic regression and similar things like that, which are basically ways of looking at data for example, that has trends in it
Yeah.
and has cycles.
Yeah.
And can you model that and forecast from it?
Yeah.
And one of the primary aims was forecasting. And we found that it uses a thing, as you know, a lot of my basic work is recursive estimation.
Yeah, which we haven't really mentioned yet, but because that underlies most of the Captain algorithms.
That's right.
Yeah.
And the best known recursive algorithm is the Kalman filter, which many people have heard about. But not so many will have heard of the smoothing, the recursive smoothing. The filtering is where the estimate at any time is based on the data up to that time.
Yeah.
It's recursive, it's processing like that. The smoothing is that the estimate at any time is based on all of the data. So you actually go forward and then you come back. And it's like double filtering, which the various ways of doing it.
And noisy data has real advantages.
It does. And when you do this two-pass, it removes the lag. So what you get out is a lag-free result. And this result is made up of various components, one of which is often a trend, and the other are various components that add together to give you the model. Now it turns out that this is generally useful. It's useful in many, many areas. So that's why it's become so popular, I think. It's all done automatically and optimised, and the various stages in it, but all of the routines are available. So I think that's been useful, as I understand it, in hydrology, though I have not been aware personally of it being...
No, but the transfer function modelling, what came to be called the database mechanistic approach in philosophy to letting the data tell you what the model structure should be is also at the heart of Captain.
It is.
So perhaps you should say a little about that philosophy.
Yes.
We mentioned it in passing, but
that's right.
Perhaps a little more.
Well, the transfer function, let's think of it in continuous time, because I think it's probably more transparent in that. If you write a differential equation between, say, the flow output, or let's say the concentration of a trace at a point downstream in relation to one upstream, and you write a differential equation for that, you might do it very simply by just saying it's a mixing volume. I think most hydrologists will be able to write down that. Then if you take the Laplace transform of that equation, which put simply means you just take the d by dt and call it s. d2t by dt squared is s squared.
Which classically was done with unit hydrographs in hydrology as well.
Right. That's right.
As a way of identifying the unit hydrograph.
I'd forgotten that, yes. So if you do that and then you form the ratio of the input polynomials in this operator and the denominator, that's called the transfer function. And all of the algorithms I've developed for linear systems are like that. So they're transfer functions. There's two stages. The first is you identify what order of model, in other words, the order of the differential equation, if it's continuous time, is most appropriate to the data. And then most people who first see this will be surprised at how lower order
you can get away with. Yeah.
For example, I've just been, in the book I'm writing now, emulating the large models that they use in climate, where the data are averaged from those to the global level.
Yeah.
And then if you look at the relationship between the forcing, which is various things including CO2 in the atmosphere, and the global average temperature, they average theirs and they produce that. If you take those data, you can find very low order models explain them very well indeed. And that's interesting because it suggests that the climate behaviour at the global level is much simpler than it would appear from these very, very low, these enormous models. So the transfer function estimation, having identified the structure, you then estimate the parameters. You get not only the estimates but the confidence in the estimates. then you can find derived parameters from that. So, for example, the steady state gain of a transfer function tells you how much is being lost or gained. Right? That is a function of the parameters you estimate. Now, in order to get that, you use Monte Carlo analysis. So you effectively generate, in that case it's the ratio of two parameters, you generate Monte Carlo simulations, and you can work out for each one the value of this, and then at the end you can find the mean value and the distribution, so you can find things out. So if you put all of that together, then you can take input-output data, you can have more than one input. It can be multivariable, but usually you handle it in a series of single output, multi-input systems.
But like the unit hydrograph, traditionally in hydrology, the transfer function is linear, as you said.
It is indeed.
And our rainfall runoff processes are non-linear, and you did come up with a very neat way of trying to identify what, again in the database mechanistic philosophy of how to identify the non-linearity with the state-dependent identification approach.
Yes.
Was that used elsewhere before you applied
yes,
it?
Yes, it had been. Because I was looking at the recursive estimation of parameters, one obvious reason for doing that is because they might vary.
Yes.
And so time-varying parameter systems are like that. In fact, you know, the hydrological data again.
Exactly, yes.
The first thing you find is that if you look at talking, to an audience who knows all about this, so I'm repeating something well known, but if you have one flow event, you'll get one model. If you do another flow event, you'll get another model, which suggests that the parameters vary. Now, is it varying? What reason are those parameters varying? And it struck me that one reason was it was a nonlinear system. So I started thinking about, well, could you use a time-varying parameter system to model a nonlinear system? So it would be a linear-like structure, but the parameters would be a function of other variables, perhaps other variables in the same system. And to my surprise, it seemed to work quite well. And it was at that time that I, with what was a previous approach to doing this, which is related but is not all that good, I found that I could find a non-linearity that would allow the transfer function with this non-linearity, which conveniently was at the input. So it seemed to be operating on the rainfall and then producing flow. Under different conditions, it produced different flows. And I mentioned this to you when you came up with all that, which was a power law, I think I found. And you said, well, a power law made sense in hydrological terms, which I didn't know.
It did, and we actually did a little bit of theory to relate it to the top model.
That's right.
The conceptual approach.
Right.
So my approach to trying to do process modelling and your approach to doing database mechanistic modelling sort of overlapped at that point.
They did, yes. So it was interesting, I think. And I'd used it. There was I think it was 6-month thing in Cambridge, which was organised by the research councils.
Oh, one of the Newton Institutes. Yes, I remember coming down to that.
That's right, yes. And I put together the stuff on state-dependent. We call this state-dependent in the sense that parameters were varying in the state. The clue to this, the method which produced this rainfall flow model, I didn't like it. It did it, but it didn't do it very well, I didn't think. And I thought long and hard, how could you do it better? And I suddenly realised that you had to change the order of the parameter of the data in order to do it, so that the order suited the thing you were looking to see if it was a function of. It's just like plotting.
Yeah.
The way you did it. And, that worked,
Yeah.
basically.
When we put things in order of discharge, you saw the power law come out.
You saw it come out
and
much
ranked by
more
discharge.
clearly.
Yes.
Yeah.
Yeah.
And then you had better measures of the uncertainty and things like this. So, and that is very widely applicable. I used it
So other
in
non-linear
various
systems,
areas. Yes. As you know, I work in other areas, so I've tended to find that non-linearity lurks about all over the place.
Indeed, yes.
And so this is one way.
Nature.
Not the only way of doing it, but it is one way. I mean, many people would say I model black box because I model these, I get simple models, but the mechanistic in database mechanism is important. I don't like to accept anything unless I can infer the mechanism from it.
The recursive methods have obvious applications in forecasting.
Yes.
So you're fitting your model up to your time, or you're evaluating your model up to the time, and then you want to forecast ahead, given the latest state.
That's right.
And one of the things we did in applying the database mechanistic models was in doing flood forecasting.
Yes.
Initially on the NIF.
On the NIF,
I think down to Dumfries.
That's right.
The pub in Dumfries that floods frequently was in the news again recently, I think.
That's
Yes.
interesting.
It's being flooded
I
again.
must admit I'd never heard of it, but I thought it was interesting that they got flood warnings by the policemen going upstream to this bridge.
Yes, that was the state of affairs at the time.
That's right. But we were fortunate in that the young man who was looking into that was interested in what we were doing.
He was an ex-Lancaster graduate.
That's right.
I think, yes.
Yeah. What was his name?
No, there you go.
There you are. I'm not alone in my thing.
Yeah.
Anyway,
It was Matthew Lees who helped develop the system.
Yes.
The other name will come back to me, I'm sure.
Yes. Anyway, you're right. I mean, basically, the recursive formulation is an ideal form for doing this. And the one thing, of course, you do find that if you want to forecast ahead, you better have what they call in forecasting a leading indicator.
Oh, yes.
So this meant that if you wanted to forecast flow in a river, you'd better have the rainfall way up in the catchment.
Mm-hmm.
So you've got a nice long period.
Or flow if the catchment is large enough.
And then you could forecast over that lag. So that's what we did.
Although one of the interesting things on the NIF was that we found that they wanted a 6-hour forecast. And the natural time delay, I think, was 5 hours, but we found we could get better forecasts by using an artificial time delay for their 6-hour requirement.
Which you often can do.
Yeah.
I think you can identify a particular model, but often just manipulating it a little bit, you get a slight degradation in performance, but often that's acceptable. It's a sort of thing. So yes, and I think you get a forecast, not only the forecast, but you have the confidence in the forecast, so you can see this expanding to the point where you don't accept it anymore. And I think the first time I think that came out, there was it a BHS meeting at the Royal Society? I don't know. There was a meeting at the Royal Society. I think you were there.
About forecasting.
Yes, and I think the first time we put it down in complete terms was then, I think. And actually that paper gets referred to a lot, so I presume it's had some influence, which is what you hope for.
Yes, that's a good philosophy. Just to finish up, Peter, you've been awarded a number of awards during your career, from the Whitworth Fellowship, which was quite important to you very early on, but is there an award that's been particularly important to you?
Well, I think the Whitworth Fellowship is really good.
Obviously.
I haven't received many awards, Keith. I've got a few medals around, but I can't even remember what they were. I think
the Whitworth was clearly important right at the beginning.
I think that was a big influence. I think if that hadn't have come through, my life, our life would have been completely different. I mean, one of the things which I'm finding now at the age of 84 is that you should keep going, because you'll get all sorts of aches and pains and other things, and you're hoping it's not the final ache and pain. But if you keep going, you keep your mind active.
Yeah.
And I've found that that's a big benefit.
Well,
and
let me just say that I hope you keep going a long time.
well, thank you. I mean, the other thing I would say is that I have to say that I wouldn't be here now and have done all this had I not met my wife. When I was 17 and she was 14, and we've been together ever since, 66 years, and it's our diamond wedding this year, and she has been an enormous help to me. I don't think anybody would have put up with her as much as she did. I mean, I work long hours.
Yes. Well,
Some
clear.
say we're workaholic.
Yes.
You know, to put up with that over many years and children.
Right, so Wendy deserves a mention.
She does.
Yeah. Okay.
She deserves a medal.
Thank you very much.